Welcome to this class again. In this class, we talk about digital inputs to the Arduino. And as our demonstration for this class, we shall develop a program using an LED and a push button. And the implementation will be such that when you press a button, the LED turns on. And when you release the button, the LED goes off. So we had earlier done the interface for the LED. But now in this case, we shall be focusing on the input from the button. So remember we had actually introduced about digital inputs and outputs. We know that Arduino has both digital inputs and output capabilities. And in this class, we focus on the input side. Earlier we did interface an LED as a digital output. So what's a digital input? When a digital pin is set as input, we can read a voltage as either high or low. So in this case, we are not outputting, we are only reading from the digital pin. High is when a voltage is greater than 3 volts is present at the pin. So, and low is when a voltage that is lower than 3 volts is read at the pin. So when set to input, the pin of the Arduino is in a high impedance state, which is equivalent to a series resistor of 100 mega ohms in front of the pin. So since very little, actually what this does, that very little current goes through the pin, and so the pin has very low effect on the circuit it's sampling, so that we don't have an interference from the Arduino to the circuit in which it's reading. So that's why we have the high impedance state that actually is already configured in the microcontroller. So digital input is coded using the digital read function. So this is how we write it, digital read, and then we specify the pin we want to read as from. So we can put a digital pin from 0 to 13 from Arduino. So any of the pins from 0 to 13 are digital pins in Arduino, and you can use them for digital inputs. So the function will return either a high or a low. So when you can actually assign that results to a variable and then use that in your logic for the program. So for example, we can say integer, of course, a high represents 1, a low represents 0. So int button state is equals to digital read, now the push button pin. You can say pin number 2. So if it's high, it will return a number 1, and if it's low, it will return a number 0. So this is a function that returns a value. That value is the state of the button. So this is the diagram, circuit diagram for our implementation, our demonstration. The LED circuit we already had earlier stated, we had earlier seen it, but now we are especially focusing on the button section. So this is how the symbol for a button looks like. This is a button. You have this pin and this pin connected together, and then this pin and this pin also connected together. But there is a gap. This is when you press it, you close this gap, and when you release it, you open this gap. So how do we connect this to the Arduino? So from any of these pins that are connected, you connect one of the pins to the Arduino. So you see this green wire is connected all the way to pin number 2 of the Arduino. And then the other pin you connect it to a 5 volts terminal. So we have connection to a pin in the Arduino, another connection to a 5 volts. That means when you close the circuit, the Arduino will read 5 volts, and that will be a high. So when it's open, we will have actually a none state. Like the Arduino will read nothing. So that's why there is a need for to introduce this section of a resistor which is connected to ground. This is to give an initial state to this Arduino when you have actually released the button. So, and this is called a pull down resistor. So this concept, let me explain it further. So normally when you have nothing, there's no press on the switch or the button, they need to be a state to the Arduino. So for example, in this pull up method, in this state, the button is not pressed. But here, the microcontroller is connected to this switch. So this resistor is pulling the state of the pin to high so that at this time, the microcontroller is reading that it's high or on. So when you close the switch or press the button, it will read low. Okay, so this is a pull-up method. So this resistor serves as a pull-up resistor, and the value normally is either 10k, 10 kilo ohms, or even 100 ohms, 100 kilo ohms. So the method we chose is pull down so that the initial state is 0. So when the switch is not pressed, the microcontroller is connected to a ground via the resistor. So this resistor serves as a pull down resistor. Again, now when the switch is closed, then there's a connection from the VCC, that is the 5 volts, to the microcontroller, and it will read a high voltage, that is 5 volts. And this resistor is actually also serves to is also a way of preventing the short circuiting of the circuit, because if it were a direct connection to ground, then you see the positive and the negative will be connected together, and that's actually dangerous in a circuit because it's called short circuiting. So this resistor also prevents the short circuiting of this circuit. So it serves as a pull down resistor. At the same time, it prevents the short circuiting of this circuit. Remember, when you connect a resistor, it limits the current. So when we have the switch turned on, the current will flow from VCC to the microcontroller, and that will be read as a digital input high. So basically, that's how we configure or connect a button to the Arduino board, as we can see in this case. So this resistor is serving as a pull down resistor so that the initial state of the button is it's low, that's the ground. That's why it's connected on the ground side. So that is it. Now let's move to the Arduino IDE so that we can program this and see the output. We are on the Arduino IDE and we want to write the code that will be used to implement our example. So we want to, when you press a push button, the LED goes on, and when you release it, the LED turns off. So we are on a blank sketch. So let's always do our documentation using a block comment. So here we want to connect an LED on pin number 7, and then a push button on pin number 2. So these are digital pins of the Arduino. So what actually our program does, that when you press the button, the LED turns on. So when you release the button, the LED turns off. So that's our logic for this case. And so let's do our setup. We want to configure digital pin number 7 as an output and digital number 2 as an input. So we use the function digital pin mode. So you remember how it's written. Pin mode pin number 7 will be an output because we are connecting an LED to pin number 7. And then pin mode digital number 2, pin number 2 as an input. So we have this setup. Now we want to give the initial state of the LED as low so that it's off when you begin. So we digital write. So we have pin number 7 to be low. So that's the end of our setup. So when you come to the loop, we want to read the state of our pin, of our button. So we said we can store that value. When we read it, we store it on a variable. So there's a better way of storing the variable, making it a global variable. So what does it mean to set a variable as a global variable? Is that you can be able to access it from anywhere in the code. So the better place is to set it here. So we call it global variable. So say integer because 0 and 1 are integers. So in C or C++, an integer is a variable of the type int. So int, so button state. So we can set it to initially to be 0. Now, so we come here to the loop. We actually do the first reading. That is to say, button state is equals to, we assign a value to it using the function digital read. Now, which pin are we reading? It's pin number 2. And actually, that's all. So let's delay for 1 milliseconds. I shall explain this on a later lecture of what we call debouncing. I'd earlier mentioned that normally the transition from low to high for digital inputs from a button is not always instantaneous as it should be. So we delay for 1 millisecond. So it's called a debounce correction. So we now know the state. And so we want to know if it's really pressed or not pressed. Now, when it's pressed, we expect it to be high or 1. When it's not pressed, we expect it to be 0 or low. So that's where we check. Now, in C++, we have a condition called, there's a method, we have something we call conditional statements that we want to check or compare two variables and see if they bring a return true or false. So we use an if statement to check the variable that we're getting from the button from what we actually expect or want to see. So we use if. Now we want to check if the button state is equals to, so this is a comparison operator. So button state, is it equal to high? And then we actually write two semicolons, not semicolons, but the square brackets, even square bracket, the brackets. And then if the button is high, then we want to light the LED on. So this is actually what we're doing here, is checking if the button is pressed. So if pressed, we want to turn the LED on. So you remember how to turn it on is digital, right? Or it's on pin number 7 and then we give it a high. So if this statement is false, that is it's not high, we say else, that means it's off, that actually the button is not pressed, then the LED should be off. So this bracket here and this bracket here to mean we are enclosing this the commands here in one section, so that it's either this or this one. So we digital right, pin number 7 to low. So let me explain once again that we have a comparison we're making, that if the button state that you have read from the button is high, that means it's pressed. Now if it's pressed, you want to turn the LED on, and by writing digital write 7 to high, we make the LED on. And if we found that it's not high, meaning it's low, it's not pressed, we turn off the LED. And so this being in a loop, it will continually be checking the button and then and updating the state of the LED. So to confirm if our code is it's correct, we remember we verify or compile by pressing this button here. Or first we need to save. So let's save it as button read. So we save. So button read and then verify. It's done compiling and so it's correct. It's actually it has no errors. So the next thing is actually to upload it to Arduino. Before then, we confirm that our board is connected and it's on the right port. That is Arduino Uno and it's on number 8. So that is it. Then now we upload. Press this upload and you see the progress here. It's uploading, done uploading. So that's it for the programming. Now let's move to the Arduino board and see how the output is.